Good afternoon, geometry students. I hope you're having a fantastic day. We are going to start a new chapter today. We finished chapter 7, talking about various angles related to polygons as well as parallelograms and other shapes. Today, we're going to start the chapter that has to do with similar polygons. So we're going to do some vocabulary, and then I have, 4 examples to go over with you. So at the top of your notes, you should just write 8.1 similar polygons, and then we'll do the vocabulary words first. So the first vocabulary words are similar polygons, and I will read you the definition, and then I will also give you 2 pictures that go with that. So similar polygons have corresponding angles that are congruent and corresponding sides that are proportional. So let's kind of write an abbreviated version of that. So the corresponding angles are congruent and the corresponding sides are proportional. Now, sometimes it can get a little confusing to keep track of the difference between 2 congruent figures or 2 similar figures. So what do you think congruent means? If someone says that 2 figures are congruent, what are they actually telling you? They're telling you that the 2 figures are exactly the same, right? So they have exactly the same sides and exactly the same angles. The difference is with similar figures, the angles are exactly the same, but the sides are what we call proportional. So for example, let's take a look at a really common 3, 4, 5 right triangle. A triangle that would be similar to that would be a right triangle that was a 6, 8, 10, with the angles being the same, but the sides being proportional. Now by proportional, we mean that the ratio of any side on the left to its corresponding side on the right is going to be the same. So for example, 5 divided by 10 is 1/2, 3 divided by 6 is 1/2, and 4 divided by 8 is 1/2. For this set of figures, the scale factor would be 1/2. Now, let's write down the definition for scale factor. Scale factor is basically side divided by side. Side divided by side. So in the example that we just did, we could say that the scale factor is, for example, 5/10, which reduces down to 1/2. Whenever we do side divided by side, we do reduce that fraction all of the way. Now let's put some letters on this triangle. Let's call this triangle A, B, C, and let's call this triangle D, E, F. And we'll do another vocabulary word. Another vocabulary word is what we call a similarity statement. So a similarity statement indicates which angles and sides in the first triangle correspond to which angles and sides in the second triangle. So it is in the format, for example, for this example, triangle ABC is similar to triangle DEF. Now, the important thing to notice is that the order here is important. Notice that A is first on this list and D is first here. What that means is that A must correspond to D. A and D must be congruent angles. So we know from this statement here that angle A is congruent to angle D. It also must be the case that angle B is congruent to E because they're both second on the list. So angle B is congruent to angle E. And then obviously the third fact we know is that angle C is congruent to angle F. Now, we can also get sides off of a similarity statement. Notice that the first 2 letters here are AB, and the first 2 letters here are DF. that means that AB is congruent to DF. And you can see that looking at the shape here. I mean, it's similar to, excuse me, AB is similar to DF. Or you know what I should actually say corresponds to. AB corresponds to DF. I want to make sure that I make this consistent with how I'm going to ask you the question in just a minute. So yeah, AB and DF would be corresponding sides. So let's write it that way. Corresponding sides would be AB and DF. We can also see, because the second two letters are B and C here and here, and E and F there and there, that the corresponding sides would be BC and EF. And then also the last three would be, the first and last letters here are A and C. So AC and as well as DF would also be corresponding sides. So we can get from this one similarity statement which angles are congruent and which sides are corresponding. Okay. All right, let's go ahead and do some specific examples. So I'm going to erase the board of all the vocabulary words. Please don't forget that if you need to pause the video or rewind the video to get some of the notes down, you should feel free to do that. Let's do example number 1, and we'll talk a little bit more about the similarity statement. We're going to make a note that triangle LJK is similar to triangle OMN. And we'll draw the triangles off to the side here. We're going to have LJK and OMN. Now it says, name all pairs of congruent corresponding angles. So let's find the congruent corresponding angles. What angle is angle L congruent to? Can you look at the similarity statement and tell me what angle is angle L congruent to? L would be congruent to O because they're both first. So I'm going to write angle L is congruent to angle O. J would be congruent to M because they're both second. So angle J is congruent to angle M. And then angle K would be congruent to angle N. So that would be the congruent angles. Now let's look at the corresponding sides. We just talked about that a minute ago. LJ, this side here, corresponds to OM, this side here. So since those two sides correspond to each other, I know that when I take this side divided by this one, I have to get the same ratio as I will for the other pairs of corresponding sides. So I know that LJ divided by OM is going to be the same thing as, let's find another pair of corresponding angles. How about JK and MN would be corresponding sides, excuse me. So JK and MN correspond to each other. So I know that the pink divided by the pink is going to be the same as the blue divided by the blue, or JK divided by MN. Can anyone finish that statement there and tell me what the last pair would be? The last pair would be to look at side LK. We'll do that, say, in orange. And NO. So I know I would get the same number if I took the length of LK and I divided it by the length of NO. So that would be example number 1. Okay, we've just got 3 more examples, and then the rest we will go over in homework. So example number 2. This has a few different parts to it, but we're going to be given a similarity statement in the beginning again. So this is quadrilateral ABCD is similar to quadrilateral EFGH. And I'm going to draw the quadrilaterals off to the side here. So this is A, B, C, D. And then over here, I will draw a larger one. E, F, G, and H. Then I'm going to go ahead and label some of the angles and also label some of the sides. And then we'll start answering the question. So the first one says, find the scale factor of A, B, C, D to E, F, G, H. Now, when we're talking scale factor, the order is important. If it isn't specifically stated, we assume going from left to right. This one is stated, and it is from left to right, but they want the scale factor of A, B, C, D to E, F, G, H. So that means left to right. So we need to find two pairs of sides that correspond to each other. Now, if I look here, I can see that A and D are the first and last letters here, and E and H are the first and last letters here. So side AD corresponds to side EH. I can also notice that side CD, and that's all we actually need. I don't need to actually do the proportion. They just want to know the scale factor. So we're just going to do side divided by side. So the scale factor would be 15 divided by 18. Then we divide by 3 and get 5/6. So that would be the scale factor of ABCD to EFGH. Now, if we want to go the other direction and find the scale factor going from right to left, so in other words, of EFGH to ABCD, then we would go backwards. So 18/15, which when we reduce is just going to become 6/5. Notice we're using the same numbers, but just the order that we write them in is different if we're going from left to right rather than when we're going from right to left. Now, the next statement, so this was part A of the question, this is part B. Part C of the question is asking us to find X. All right, let's go ahead and put X here. And this is what I was starting to do a minute ago. To solve for X, we want to set up a proportion. Now, I know that side divided by side for this problem, if I'm reading from left to right, is 5/6. So I can take any side on the left, divided by any side on the right, and get 5/6. What that means here, because these two numbers are on corresponding sides, notice that DC is the last two letters here, and GH are the last two letters here. So I know that 5/6 has to be the same as 20/x. Again, I'm going from left to right. So I can cross multiply and get 5x equals 20 times 6, which is 120. Then I just divide by 5, and then I get that x is 24. So that's how I would solve for x. Part D is asking us to solve for y. Now again, I know that side divided by side is 5/6. And now I just need to find which pair of sides I'm going to use for the y. Since the y is over here on side BC, and side BC corresponds to side FG, I need to take y divided by 21. So I'm going to say 5/6 equals y/21. Again, I cross multiply, and I get 6y equals 21 times 5, which is 105. Divide both by 6, and I get that y is 17.5. So that would be part D of this problem. All right, part E is going to ask us to find the measure of angle EFG. EFG, so that would be this angle here. Again, looking at the similarity statement, we can see that angle B and angle F are congruent. So B and F are congruent. So if B is 134 degrees, angle F also needs to be 134 degrees. And then the last part of this example, part F, is asking us to find the measure of angle CDA. CDA would be this angle here. We can see that angle D is last here, so it corresponds to the angle that is last there, which is H. So angle D and H have to be congruent. Therefore, since H is 81 degrees, angle D is also going to be 81 degrees. So that would be example number 2. All right, let's go ahead and do another one. We've got 2 more left. You guys are doing great. So, for the third example, we are given that triangle DEF is similar to triangle GHI. Let's go ahead and draw 2 triangles on the right to model that. So I have DEF and GHI. Now, because of the similarity statement, I can see that D is corresponding to G, so they've got to be congruent. E corresponds to H, and F corresponds to I. It can be kind of helpful to mark that up in the beginning. Now, it says that the scale factor of DEF2 triangle GHI is 9:4. So keep in mind that scale factor just means side divided by side. So if they're telling me that the scale factor of DEF to GHI is 9/4, what that means is when I take a side on the left divided by a side on the right, I need to get 9/4. So this is a little bit tricky, but notice part A is going to say find GI over DF. Let's highlight that with a marker. GI and DF. Notice if I was taking side divided by side going from left to right, it's 9:4. So for example, this could be 9 times something and this could be 4 times something. However, if I'm going from right to left, it would be 4/9. So going right to left is going to give me 4/9. All right, now let's look at this a little bit further. For part B of the question, it says if DF is equal to 18, find GI. Now we can either go from left to right or right to left. I usually like to go from left to right, so let's use this number here. Going from left to right, we've got 9:4. So I know left to right is 9/4. And DF is 18. So that would be 18 over, we'll call this X. 9/4 has to be the same thing as 18 over X. I cross multiply, so I get 9 times X, and then 18 times 4 is 72. And then I would just divide both sides by 9, and I would get that X is 8. Okay, let's try another one. For part C, it says if GH is 7, so we'll make that be 7, find DE. Let's call that Y. again, let's go from left to right. The scale factor from left to right is 9/4. So if I compare corresponding side to corresponding side, I would have y/7 going from left to right. So 9/4 equals y/7. When I cross multiply, I'm going to get 4y equals 63. Then I divide both sides by 4 and get y equals 15.75. Now I know it kind of sucks to get an answer that is a decimal or a fraction, but that does happen a fair amount in this chapter, just because most of the problems involve using fractions, because we're doing a side divided by a side. So it is fairly common to get answers that are fractions. Okay, we're going to do the last example, example number 4. On this example, we're going to look at 2 pentagons. Let's see, 1, 2, 3, 4, 5. Yep, these are pentagons. So we're going to have a smaller version and a larger version. And then let's go ahead and mark this up. 1, 2. I think I have an extra side in here, so I've got 1, 2, 3, 4. Yep, I did one too many sides. All right, let's make this one go out a little bit longer. So I've got 1, 2, 3, and 4. All right, we'll call that A, B, C, D, and E. And then we're going to label these sides. This is 15. This one is 20. And it looks like these 3 sides are all 10. Now let's go ahead and look at the other figure, which is the same basic shape, just larger. So we have A, B, C, D, E, and P, Q, R, S, T. All right. So it says in the beginning here, A, B, C, D, E is similar to P, Q, R, S, T. Notice that that allows us to mark up which angles are congruent to which. So A is congruent to P, B is congruent to Q, C is congruent to R, D is congruent to S, and E is congruent to T. I've just marked different numbers of arcs on each angle. The first thing says, find the scale factor of ABCDE to PQRST. Scale factor, again, just means side divided by side. So we need to find 2 corresponding sides. Notice that we only have one number over here. So we want to find the side that corresponds to that on our other shape. If we look here, the side that's marked with a 21 is between the angle that's marked with 1 arc and the angle that's marked with 2 arcs. So if I go over here, and again, that's side PQ, it's the first 2 letters over here. That is going to correspond to the first 2 letters on the other shape, or side AB. So if I want to do scale factor going from left to right, and scale factor means side divided by side, it's going to be 15 divided by 21. And then again, we have to reduce it and get 5/7. So that is our scale factor. Now, the second point says to find the perimeter. So find the perimeter of PQRST. Now, one of the theorems that we bring up in this section of the book is that the ratio of the perimeters is going to be exactly the same as the ratio of the sides. So the ratio of the sides is 5/7, that has to be the same thing as the first perimeter on the left divided by the second perimeter on the right. We don't know what the perimeter on the right is, so we're just going to call that P, but we can add up the perimeter on the left. 20, 30, 40, 50, 65. And then we just cross multiply. So we get 5 times P, which is 5P, is equal to 7 times 65, which is 455. Then divide both sides by 5, and we get that P is 91. So even though we didn't have all the sides of that second figure, we could still find the perimeter because we were comparing the ratio of the sides to the ratio of the perimeters. Now, we can also find the ratio of the areas. The ratio of the areas is going to be the scale factor squared. So if the scale factor here is 5/7, it would be 5/7 squared, which is 25/49. Now in this particular problem, we were not asked to actually find the area of the second figure, but if we had been given the area of the first figure, we could set up a proportion with this ratio right here in order to do that. So that's it, guys. You just finished your 8.1 notes. Congratulations and have a good day.